So, what if the biggest new threat to your network was already inside? And what if it was completely invisible to all your existing security tools? Well, that's the reality we're facing with autonomous AI agents. They're not just another program, they are a brand new class of actor with some really deep system access. Let's break down what that really means and how you can secure it.
So let me ask you a question. Straight up, imagine an AI agent is on your network right now, as we speak. Are you 100% sure you could even see it? And maybe more importantly, could you tell if it started doing something, well, something it shouldn't? This is the fundamental problem we're going to unpack today.
And this leads us right to what we're calling the AI agent blind spot. And look, this isn't just some small crack in your defenses. It's a massive, fundamental flaw in how we see our own systems. You know, if the software we're running is changing this drastically, our entire security mindset has to evolve right along with it. I mean, we are in a completely new era. We're seeing this explosion of really powerful agents. You've got OpenClaw, Devon, Claude Code, you name it. And to be useful, they're designed for incredibly deep system access. The problem is, our security tools just haven't kept up. And it's that gap, right there, between the rapid adoption of these agents and the lagging security, that's where the real risk is hiding.
Okay, so you're probably asking, wait, why can't my existing multi-million-dollar security stack handle this? And the answer is actually pretty simple, and honestly, it's a little bit scary. They're built to fight a completely different kind of war.
Let's just walk through this, because it is so important. Your EDR, it's looking for a known bad guy, a piece of malware with a signature. But a rogue AI agent, that's a trusted process that suddenly goes bad. Your SIEM sees all the activity, but it's like trying to read a foreign language. It has absolutely no context for what bad even looks like for an AI. And your UBA, it's designed to profile humans, not a non-human actor that thinks and acts at machine speed. Every single one of these tools fails for the same fundamental reason. They lack AI-native context.
And this quote just nails it perfectly. It's brilliant. The problem isn't that your antivirus or EDR is bad. It's that you're asking it to do a job it was never, ever designed for. You're using a metal detector to find a wooden boat. You're simply looking for the wrong kind of threat.
So if the old guard fails, what does the new guard even look like? Well, we're going to talk about a framework called Silo, which isn't just another tool. You have to think of it as a completely new philosophy, one that's designed from the ground up for this very specific challenge.
So the first big idea from Silo is the Trust Deficit Score, or TDS. You can pretty much think of it like a credit score, but for an AI agent. Now, instead of getting a simple good or bad alert that just floods your security team, TDS is a continuous score. Small, kind of suspicious actions? The score goes up a little. A long period of perfectly normal behavior? The score goes back down. It's a model that's built for the shades of gray where these agents actually operate.
And this is where it gets really, really smart. That trust deficit score is directly tied to a proportional response. When the agent is behaving and trust is high, Silo just watches, it just observes. But as that score starts to creep up, it might gently tap the brakes, maybe slow down its network access. If things get worse, it isolates the agent from critical files. And only when it hits a truly critical level does it step in and terminate the process. This whole approach prevents overreactions and lets the agent do its job productively, unless it genuinely goes off the rails.
And the crucial difference here is speed. An AI operates at machine speed. A human response is it's way too slow. Just look at this table. An analyst takes, say, 15 minutes to review an alert about SSH key access. By that time, those keys are long gone. Silo, on the other hand, isolates that connection in less than 100 milliseconds. That is the difference between a minor incident and a catastrophic breach.
Okay, but hold on. That raises a really critical question. If you have a super smart AI, what's to stop it from just turning off the monitoring software that's watching it? And this brings us to what might be the single most important concept here, the absolute need for an untappable foundation.
So Silo's entire approach is to anchor its monitoring deep down, in the hardware itself. It's this tiered system, moving all the way from software checks up to custom silicon. By using hardware features that are already there, like Apple's Secure Enclave or Intel's SGX, it creates a protected, isolated space where the monitoring process can run completely safe from the AI it's watching. The agent literally cannot touch it.
And this analogy just makes it all click. It's perfect. Any monitoring tool that's pure software is like a security camera you just plug into the wall. A clever intruder or a rogue AI can just find the plug and pull it. But hardware-rooted trust, that's totally different. That's like building the camera and all of its wiring directly into the concrete foundation of the building. It simply cannot be unplugged.
Okay, so enough with the theory. How does all this actually play out in the real world? Let's take a popular agent that teams are using right now, like OpenClaw, and see how Silo would handle it.
This table shows you exactly what would happen. Let's say an OpenClaw agent starts sniffing around in your SSH credentials folder. Boom! Its trust deficit score spikes by 40 points, and Silo instantly isolates it from the network. What if it tries to use sudo to get root access? Well, that's a critical threat. The score jumps by 50, and the process is terminated right on the spot. It's a clear, automated, and decisive response every time.
So with a threat this obvious and this big, you would think the market would be absolutely flooded with solutions, right? Well, it turns out the number of direct competitors playing in this specific space is 0.
And this slide, wow, this is really the knockout punch. It lays out all the major categories of security tools, your EDRs, SIEMs, cloud security, even AI model security. And it points out that none of them have any awareness of what an AI agent is doing at runtime. I mean, tools from Hidden Layer or Robust Intelligence, they're great, but they focus on the LLM model itself, not what an agent using that model is actually doing on your server.
So what does all this mean? The main takeaway is this. This is not about a better product in an already existing category. This is about the creation of a brand new category, runtime security for autonomous AI agents. And for right now, Silo is the only name in that game.
So what can you and your team actually do right now? The guidance here is really clear. Start in observe-only mode to get a baseline of what normal agent behavior even looks like in your specific environment. Use allow lists for your known workflows to cut down on the noise. And always keep an eye on that OpenSlog gateway port, 18789. The goal is to get ahead of the problem, not be stuck reacting to a breach after it's too late.
And that really leaves us with this one final thought. Your developers, your business units, they are going to deploy these powerful AI agents. Why? Because the productivity gains are just too massive to ignore. They are coming. So the real strategic question for every single security leader out there isn't if you're going to face this challenge. It's whether you'll have the visibility and the control you need when you do.
Really leaves us with one final crucial question, a question you really need to ask yourself. When you look at the rise of autonomous AI, and it's not a matter of if, but when, you have to ask, is my organization's security architecture built for the past, or is it ready for the future?